Hey everyone, Mr. Hauk here. In today's video, we're going to continue learning about circles. In particular, today we're going to look at graphing circles given an equation, and if we're given the graph of a circle, can we derive its equation? Recall from the previous lesson that circles can have two forms of an equation. We can have the general form, which is given right here. I'm going to zoom in. And remember that the general form of a circle, not very useful. Then we have the standard form equation, which is right here, which we derived in the previous lesson using Pythagorean's theorem. The standard form equation is much more useful because we can easily identify the center, hk, and the radius r, just by looking at the standard form of the equation. Now, graphing circles is going to be a pretty straightforward process because all we have to do is find the center of the circle and then use the radius to plot points that are going to lie on the outside of the circle. And then that's going to allow us to sketch the graph pretty easily. So let's see a couple examples here. In the first example, we want to sketch the graph of the circle given by the equation x plus 2 squared plus y minus 4 squared equals 9. Notice that this is already written in standard form for us. Remember, standard form is x minus h squared plus y minus k squared equals the radius squared. And what that's telling us is that hk, the center, is going to be -2, +4. Remember that the signs are going to need to change because in the standard form equation, we have these negatives in front of h and k. So our center, let's go ahead and record that. Center is going to be -2, +4. And then the radius, well, we see that in the standard form equation, the constant on the right side is the radius squared. So if I want to find the radius, I just need to take the square root of the constant on the right. Square root of 9 is going to be 3. And now let's use this information to go ahead and sketch the circle. So I'm going to plot the center at -2, 4, which is right here. And we're going to use the radius of 3 to go ahead and find some points on the exterior of the circle. So go start at the center. Let's go 3 out in each direction. So 3 up, 3 right, 3 down, 3 left. And for me, I get to cheat a little bit because in GoodNotes here, I have a shape recognize tool. So I'm going to go ahead and do a terrible drawing, but GoodNotes is going to save me with the shape recognition. And here's my sketch of the graph. Remember, sketch doesn't need to be 100% accurate. In fact, I don't even like that too much. Let's try that again. See if we can get a little bit better. A little bit better. We see the points there, okay? But that's the sketch of the graph. Remember, what was important here is that we identified the center and the radius, plotted the center, used the radius to find some points on the outside of the circle, and that allowed us to sketch a graph of our circle here. Let's try one that is a little bit more involved. Notice that this time, we still want to sketch the graph of the circle, but our circle is not in standard form, it's in general form. And we learned in the previous video that if we want to find the center and the radius, that we're going to need to convert from general form to standard form using completing the square. So let's go ahead and jump into that process here. First thing I'm going to do is I'm going to start grouping the x's and y's together. So x squared minus 6x. I'm going to leave a little blank for the constants that we know we're going to eventually have to have in. Then we're going to have y squared plus 2y. Leave a little blank. And I'm also going to go ahead and move this constant to the right side of the equation by subtracting it. Okay? And now we need to think to ourselves, well, we need to create some perfect square trinomials here. We need to know, what will I add here with the x's? What will I add here with the y's to start creating some perfect square trinomials? Well, let's think about it here. If this constant term was a 9, then x squared minus 6x plus 9 would factor into x minus 3 times x minus 3. Similarly, if this constant term was a 1, then y squared plus 2y plus 1 would factor into y plus 1 times y plus 1. Now, remember that these constant terms here, this plus 9 and this plus 1, we can't just simply add numbers into an equation on one side because it throws off the balance of the equation. So since we added 9 and we added 1 on the left, we need to make sure that we add 9 and we add 1 on the right side. This keeps our equation in balance. So on the right side, -1 plus 9 plus 1, that's just going to give us 9. And then simplifying here, this would be x minus 3 to the second power plus y plus 1 to the second power equals 9. And now that we have converted our circle from general form to standard form, we can now go ahead and identify the center and the radius very easily. So for the center, we can see the center is going to be positive 3, negative 1. We're changing the signs there. And the radius, well, if we look at the constant on the right side and we take the square root of it, we can see that the radius is going to be 3. And now we can go ahead and plot the center. So the center, 3, negative 1, be right there. And the radius is 3. We know that the distance from the center to any point on the exterior of the circle should be 3. So let's just go ahead and sketch a few points in here. Radius of 3 would bring us here. We'd have a point right there at 6, negative 1. We'd have a point at 3, negative 4. And we'll have a point at 0, negative 1 right there. Okay. I'm going to use my shape recognition tool. I'm going to cheat a little bit here. Terrible circle. Boom. Now a much better circle. And there's the sketch of our circle. Again, a little bit more involved process because we had to convert from general to standard form using completing the square. But once we were there in standard form, it was very easy for us to find the center, the radius, and then go ahead and sketch the graph. So now let's kind of work in the opposite direction. Instead of having an equation and trying to sketch the graph, let's look at when we have a graph and we want to write the equation. Well, again, it's going to be a pretty straightforward process because all we have to do is identify the center, identify the radius based off of the points on the circle, and once we've done that, we can plug the center and the radius into the standard form equation, and that's going to give us an equation for the circle. So let's look at a couple quick examples here. We want to write the standard form equation of the circle graph below. I'm going to highlight standard form. It's also bolded. So for standard form, we just need to know the center and the radius. Well, the center is pretty easy to pick out. It's going to be -3, -2. And the radius, we just look for the distance from the center to any point on the outside of the triangle. Or sorry, not triangle, but circle rather. And we can see pretty easily that the radius is going to be a 2. Okay, so center, -3, -2. That's our h and our k. Radius is equal to 2. All right, and now let's plug that into our standard form equation. We know the standard form equation is x minus h to the second power plus y minus k to the second power equals r squared. Well, h is -3, so x minus -3 squared plus y minus, let's see, k is -2, so y minus -2 squared equals r squared, so that's going to be 2 squared. Simplifying a little bit here, x minus -3, that's just x plus 3 squared plus y plus 2 squared equals 4. And this is standard form, so we are done. Moving over here to our next example, we want to write the general form equation of the circle graph below. Same basic principle here. Let's go ahead and find the center, find the radius. We're going to end up writing our circle equation in standard form, and then we're going to FOIL the perfect square parts into to expand it, and that way we can collect the like terms and we'll be in general form from there. Okay, so that's the strategy. Let's go ahead and apply it here. The center of our circle this time is going to be a 1, +3. And we can see pretty easily that the radius is going to be +2. So I'm going to write those pieces down. Center, 1, 3, and radius, positive 2. Let's go ahead and write our standard form. I'm not going to go through and do all the tiny little steps that we did over here. We know that the center is 1, 3, so we know we're going to have an x minus 1 squared plus y minus 3 squared. And we also know that the radius is 2, and we know that the radius ends up getting squared, so 2 squared, that would be 4. Okay, so if we wanted the standard form equation, this is what we would get. X minus 1 squared plus y minus 3 squared equals 4. We want the general form equation, so let's go ahead and start expanding this. So x minus 1 squared, that's obviously x minus 1 times itself, plus y minus 3 squared, which is just y minus 3 times itself, equals 4. Let's go through and start foiling. So x times x is x squared, x times negative 1, negative x, negative 1 times x, we get negative x again, and then negative 1 times negative 1, we get positive 1. Doing the foiling process again with the y, y minus 3 times y minus 3, so y times y would be y squared, y times negative 3, negative 3y, same thing for negative 3 times y, and then negative 3 times negative 3, we get positive 9. And one thing I'm actually going to do, let's save ourselves a step. Let's go ahead and take this 4 and subtract it over here. So we'll subtract this over as a negative 4 and set this equal to 0. And now we're going to do one big collection of like terms. X squared doesn't have a like term. Y squared doesn't have a like term. Negative x and negative x is negative 2x. Negative 3y and negative 3y is negative 6y. And then looking at the constants, 1, 9, and negative 4. So 1 plus 9 is 10. 10 minus 4 is going to be 6. And that's our general form of the circle. Okay, x squared plus y squared minus 2x minus 6y plus 6 equals 0. And notice in the general form, notice how the coefficients, or not the coefficients, rather the degree, what am I trying to say here? Not the degree. Notice that it's going by highest exponent. That's what I was trying to say. So x squared plus y squared, then you have the x and the y variable, and notice that the constant is going last, and that is equal to 0. That's what we were accomplishing over here. That's why when I started collecting some of the like terms, I put the x squared first, the y squared second. Those went first and second because they had the power of 2. Then I started collecting the x variables, the y variables, and the constants went last, and I made sure to set it equal to 0. Okay. All right, in our last example, we want to write the standard form equation of the circle with ends of a diameter at negative 4, 4, and negative 6, negative 6. So let's think about this for a second. If these are the endpoints of the diameter, then the middle point, the midway point, is going to be the center of the circle itself. So the midpoint of a circle's diameter is going to end up being the center. So to find the center, we just have to find the midpoint of those two endpoints on the diameter. So we're going to use the midpoint formula. So we have, let me get a different color here. Let's do black. All right, so we have the points negative 4, 4, and negative 6, negative 6. Let's go ahead and call negative 4, 4. This is x1, y1. This will be x2, y2. And the midpoint formula, and remember the midpoint is going to give us the center, so I'm going to say HK. So the center HK is going to be the midpoint, which is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is our midpoint formula. Well, let's plug in the pieces here. x1 plus x2, that's going to be negative 4 plus negative 6 over 2. y1 plus y2, that's going to be 4 plus negative 6 over 2. Simplifying, negative 4 plus negative 6, that's negative 10 over 2. 4 plus negative 6 is going to be negative 2 over 2. And that's going to tell us that the center of our circle is -5, -1. Okay, so that allowed us to find the center. But if we're going to write the standard form equation, we want the center and we need the radius. So to find the radius, well, now that we know the center, if I can find the distance between the center and either of these endpoints, either of these endpoints of the diameter, then we can find the radius, because that's what the radius is, the distance between the center and any point on the circle. So now we're going to use the distance formula with our center, and any of these points, I'm going to choose -4, 4, doesn't matter, and the center, -5, -1. Again, I'm going to label x1, y1, x2, y2, and this time we're going to use the distance formula. So the radius is going to be the distance. That's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, x2 minus x1, that's -5 minus -4 squared, plus, let's see, y2 minus y1, that's -1 minus 4 squared. Continuing to simplify, -5 minus -4, that's -5 plus 4, which would be a -1, so we get -1 to the second power, plus, let's see, -1 minus 4, that's -5 to the second power. And we're almost done. -1 squared is 1, -5 squared is 25, and this gets us the square root of 26. So we found the pieces that we need. We found the center, which is -5, -1. We found the radius, which is the square root of 26. And once you know the center and the radius, you can very easily find the standard form equation. So we know standard form equation, x minus h squared plus y minus k squared equals the radius squared. We know that since the center, hk, is -5, -1, we're going to have x plus 5 squared plus y plus 1 squared equals r squared. Well, the radius is square root of 26, so if I do square root of 26 squared, the square root and the power of 2 will just cancel each other, and this will just give us 26. And that gives us our standard form equation of the circle with the ends of a diameter -4, 4, and -6, -6. Now, before I end the video here, I want to show you how you can check a lot of the work here using Desmos. So let's go back to some of these examples from the beginning. For example, we want to check, in our first example, we wanted to sketch the graph of the circle given by x plus 2 squared plus y minus 4 squared equals 9. So if I pull up just a Desmos graphing calculator, and if I plug in that circle equation, so x plus 2 squared plus y minus 4 squared equals 9. Notice that Desmos is going to go ahead and graph the circle for us, and it's very easy to figure out what the center of the circle would be. We can see some pretty clear points on the circle as well. And if we jump over to our notes, for example, when we sketched it, we found that the center of the circle was -2, +4, and one of the points, for example, was -2, 1. So if I jump back over to Desmos, well, here it is right here, -2, +4. We can see the center of the circle pretty clearly, and then -2, +1, right there at that gray point, is also a point on the circumference of the circle. So we can see that our sketch was accurate and everything turned out pretty good. Okay, so Desmos can be a powerful tool to help you check some of your work here with circles. I'm not going to go through and take the time to check all the circles from these notes, but just know that as you're working through your examples, or as you're preparing for your quizzes and tests, or taking your quizzes and tests, Desmos can be a very powerful tool for graphing circles. Okay, so to kind of recap, in the previous video and in this video, we talked about circles, standard form, general form, how to derive circles, how to find the center and the radius of a circle. In the next video, we're going to start looking at ellipses, which is going to be a pretty fun topic.